Hey y'all, we're going to be talking about how perimeter is affected by scale factor today. So we're going to watch two short videos and I'll make some comments as we watch them.
When you dilate a figure, your perimeter changes by your scale factor. Let me explain what I mean. Let's say we take this rectangle and we use a scale factor of 1.5 or 1.5. That would create sides that were 1.5 times longer and a length 1.5 times longer. So 2 times 1.5 is 3, 6 times 1.5 is 9. Label all of your sides of your figures. Now our original perimeter was 12 plus 4 16.
She got that perimeter by just adding up the sides of this rectangle. So 6 plus 2 plus 6 plus 2 gives you 16. And I know that you learned in class how important it is to have a unit here. So just make sure that you have written on your paper 16 centimeters or 16 inches or whatever the given unit is.
And our new perimeter is 12 plus 12. Our new perimeter is 24. Now you can draw a picture and work it that way, or you can use your knowledge that the perimeter will be 1.5 times longer. You could take your old perimeter times your scale factor should give you your new perimeter. So let's try that out. Our old perimeter was 16. Our scale factor was 1.5. 16 times 1.5 is 24, and that was our new perimeter.
So here she's showing you how to find the perimeter of a figure that's been dilated by a scale factor. You could, just like she did, take the new rectangle and find all the side lengths and add them up, but it's a lot faster to just multiply by the scale factor, which is what we want you guys to do. So take 16, the original perimeter, multiply it by the scale factor of 1.5, and you'll get the new perimeter of 24. It's a lot faster than redrawing the figure. We're going to go through another example with a circle.
This idea also works with circles and circumference. So if we have a diameter of 10 on a circle, we know the circumference is about 3 times around, so we know the circumference of this circle is about 30. So if we dilate it again, let's use a scale factor of 1.5. So our diameter will be 10 plus another 5. So our circumference here, so our diameter is now 15.
So I want you to take a second and think through, how could you calculate the new circumference given the old circumference? So what would you have to multiply 30 by to get this new circumference?
Which means our circumference is about 3 times that much, about 45. Now, could we have used old perimeter times our scale factor equals our new perimeter on the circle, even though perimeter is pretty much the same word for circumference for a circle? So let's try it. We had 30 times 1.5, and sure enough, we got 45.
So to calculate a new perimeter given an old perimeter, just like it says down here, you'll take the old perimeter and multiply by the scale factor to get the new perimeter. We're going to go through a specific example from your Go Math book that shows you how to do that.
Okay, so let's look at the effects of dilation on perimeter and area. So we'll start off by reading our example. We have a rectangle has a width of 3 centimeters and a length of 4 centimeters. Another rectangle is dilated from this rectangle with a scale factor of 2. Okay, so this is giving us our pre-image. So we have, let's go ahead and draw our rectangle. Okay, so we have our width is 3 centimeters. Our length is equal to 4 centimeters. So this is going to be our P, or our pre-image. Okay, so this is going to be our pre-image. So now we have, to start off, we have, let's look at our, so 3 centimeters is our width, and then we have a scale factor of 2. So the first thing that we want to do is we want to find the perimeter of our pre-image. Okay, so we're going to use, for P, equaling 2L plus 2W. So again, this is our pre-image. Okay, this is
If you aren't familiar with this equation, that's okay. 2L plus 2W is just the equation for perimeter, which makes sense because you take this length of 4 and add it twice, because you'll have another length of 4 up here. Take this length of 3 and add it twice, because you'll have another length of 3 over here. If you don't want to use this formula, just use what you know of adding up all the sides of the figure to find the perimeter.
This is what we're starting with. So we're going to substitute in the values of L and W, or the length and width. So we have 2 times L, which is 4 centimeters. So 2 times 4 plus 2 times W, and our W is 3. So 2 times 3. And then we have, if we simplify that, 2 times 4 is 8, plus 2 times 3, excuse me, that's 6. So 8 plus 6 is 14. So we have 14 centimeters is our P, or our pre-image, the perimeter of our pre-image. And then the second thing that we need to do now is find the perimeter of the dilated rectangle. So step 2, this is going to be our image. So I'm going to do it sideways for just a moment. So this is our pre-image. Okay, so that's our pre-image. And now we're going to find the perimeter of the dilated rectangle.
So in the first video, she redrew the rectangle and found each side length. This is the faster way. You don't have to redraw the triangle or the rectangle.
This is going to be our image. Okay, so for P prime, the formula is, it's going to be the perimeter times the scale factor. Okay, so the perimeter times the scale factor. So we found our perimeter in step 1. Our perimeter is 14. And then times our scale factor, we're given a scale factor of 2. So times 2. And that equals 14 times 2 is 28, and our measurement is centimeters. So our perimeter of our image, or our dilated rectangle, is 28 centimeters.
Notice that she included a unit. Don't forget to include units on your answers.